Trends are one of the important phenomena that evolutionary biologists investigate. These include situations where a group starts out with one kind of structure or lives in one type of habitat and eventually evolves another type of structure or moves to a different type of habitat. For instance, the earliest horses had several toes and were small, while modern horses have just one and are large. Birds evolved flight from non-flying dinosaurs. Arthropods invaded land from the ocean, etc., etc. The classic neo-Darwinian explanation treated these trends as the result of gradual and directed anegetic changes within lineages, driven by selection for a particular feature. For example, when it came to horses, these were once explained via the following scenario. Start out with a small horse-like ancestral population with 3 toes, apply selection pressure for large size and speed, and after tens of millions of years, end up with a large, fast horse with a single toe. Certainly, this explanation is simple, maybe it's even elegant, and it definitely does not focus much on the existence of species, nor does it treat them as real or of much importance. The problem is elegant or not, it's wrong. Eldredge and Gould, with their formulation of punctuated equilibria, dramatically changed our understanding of trends. Punc-eq placed a species front and center in macroevolution. Their framework indicates that trends were not the result of directed transformation of single lineages, but rather were caused by differential speciation and extinction within a clade. Further, individual species spend a good deal of time, indeed most of their existence, simply persisting, so they are not being continually modified, or at least directionally either. With Punc-eq, macroevolution in general and trends in particular are about the patterns and processes related to the birth, death, and persistence of species. Further, with Punc-eq, species are real and stable for most of their history. Returning to our example from horses, this means we cannot simply extrapolate selection pressures in a single population over tens of millions of years to go from a tiny ancestor of horses to the large modern horse. Instead, we actually need to consider the factors that influence speciation and extinction in the horse clade, and thus many species containing innumerable populations over tens of millions of years. These factors would especially be changes in climate and geology that led to opportunities for allopatric speciation or caused extinction. We would also have to ascertain why over much of their history and in the face of consistent natural selection, most horse species were changing little if at all. Yes, perhaps understanding and reconstructing trends is more complicated now, but it's also a lot more accurate, and maybe it's a lot more interesting too.